All right, so today we're going to be talking about the vertex form. So vertex form might be one of the easier forms of the quadratic function as far as graphing it, because it basically gives me all the transformations I need in order to find the vertex just by looking at it. So this is where we have it set up with some kind of square thing happening, but it's going to tell me where the vertex is from the transformations. Because if I do x squared as my quadratic, y equals x squared, that's a quadratic that's starting at the origin and going, over 1, up 1, and then over 2, up 4, so on, so forth, right? That is just the normal x squared quadratic. This is taking that quadratic and shifting it left or right or up or down, or it's flipping it over the x-axis or the y-axis, which flipping over the y-axis is the exact same in quadratics because it's symmetric. So just flipping it over the x-axis would change the quadratic. It would flip it upside down, right? So if we look at number 1, I've got 3 things happening to what was normally x squared. If I thought of this as normally x squared, I've added a minus 4 in the parentheses with the x. I've added a 1 afterwards, and I've put a negative in front. Okay? So what this does is this is going to shift it to the right 4 spots, this is going to shift it up 1 spot, and this is going to flip it upside down. So when I go to start it, so this tells me exactly where the vertex is going to be. So the vertex is going to be to the right 4 and up 1. There's my vertex. So it would be 4, 1. Okay, not too tough. Now, since I know what the vertex is, I also know what the axis of symmetry is, right? Because the axis of symmetry goes right through the vertex. So it has to be the vertical line that goes through 4, 1, which is x equals 4. Okay, so now I know all of that stuff. I just make my table, just like I normally would. And I'm going to use 5 values. And I'm going to use the vertex, and I know it's already going to be at 1. And then I just plug in everything else. So I'd have the 2 numbers before it, and then 2 numbers after it. And then when I plug them in, 3 minus 4 is negative 1. Negative 1 squared is 1. 1 times negative, it's negative 1, plus 1 is 0. Okay, 2 minus 4 is negative 2. Negative 2 squared is 4. Becomes negative 4. And then plus 1 would be negative 3. Double check that I did that. Negative 4, negative 2, be 4, the negative 3. Yep. Okay, so when I plot those at 3, it's at 0. At 2, it's at negative 3. Okay, which also means 5 would be at 0, and 6 would be at negative 3 as well. And that is my parabola, just like that. Okay, now let's look at this one right here. We have 2x squared minus 3. Negative 2x squared minus 3. So again, starting with my vertex, this 2 actually doesn't do anything but compresses my parabola, makes it a little bit more straight or steeper, I should say. But the negative in front would flip it upside down. This 3, because it's not actually in the parentheses, it's not going to be a horizontal change, it's going to just be a vertical change. So it's going to move it down 3 spots. So basically my vertex is still going to be at 0 on the x-axis, but it's going to be down 3 spots at negative 3. So there's my vertex. And then that also gives me my axis of symmetry, which again, if x is 0, it would be at 0. So my axis of symmetry is basically just the y-axis. It's going to be split by the y-axis. And then I would make a table, and I have my 5 values here. I put my vertex in the middle, so 0, 3, negative 3, sorry. And then I'm going to have the numbers before it. So negative 1, negative 2, the numbers after it, 1, 2. And when I plug those in, negative 1 squared is 1, times negative 2 is negative 2 minus 3 is negative 5. And then negative 2 squared is 4, times negative 2 is negative 8. This is going to be way off the graph. Negative 8 minus 3 would be negative 11. And then I also know this would be negative 5 and this would be negative 11 because they're symmetrical. So at negative 1, it's at negative 5. I told you it's going to make it steeper. And then at 1, it's at negative 5, and then these are clear off the graph. So it's a steeper parabola there. And that's all you're doing for the vertex form. Not too tough, right?